work via feedback systems where conditions are sort of monitored and adjusted, turning glands on or off. And one of the important ones we talked about was the pancreas producing insulin to regulate blood glucose. Okay. Now we went on and talked about some of the endocrine glands, some of the important ones. Pituitary gland, thyroid gland, pancreas, adrenal glands. And again, each of them works in a similar way, producing a hormone, a chemical messenger that affects the body in some way. So our last two that we'll talk about are sort of endocrine organs, but also reproductive organs at the same time. Because lots of these organs have multiple functions, just like pancreas produces insulin, but also produces digestive enzymes. So gonad, that word is like a general term for reproductive organs that produce reproductive cells. So the gonads in the male are the testes, female they're ovaries, okay, and they're similar and they have similar functions. In males, the testes, there's two of them. Okay. Our last body system is actually human reproduction, so we'll save the good stuff for then. But for now, we'll just talk about endocrine functions. Yeah. The testes are responsible for producing what hormone? Testosterone. Name should make sense. So the testes produce testosterone, and levels of testosterone that are produced, that's going to vary throughout a male's lifetime.
Are there any individuals left?
Yeah, don't worry about it. The testes are also responsible for producing sperm cells, and again, we'll talk about that in the reproductive system. But testosterone is the male sex hormone, and it's responsible for development of what we call secondary male sex characteristics. So those are sort of things that you typically think of as male characteristics. Obviously there are differences in anatomy, but these are other things beyond that. Secondary male sex characteristics would be things like a deeper voice, okay? More body hair, an increase of muscle mass. These are things that are related to the male sex hormone testosterone. And like I said, testosterone levels vary throughout a lifetime, increasing during puberty, later on in older, later middle age, they tend to drop. But they vary throughout a male's lifetime. Ovaries produce what hormone? Estrogen. Okay. Again, two ovaries. And they produce estrogen. They also, what's the equivalent of sperm cells for a female? Yeah, egg cells. They produce egg cells. And estrogen is responsible for the development of female secondary sex characteristics. Again, the sort of characteristics that we typically think of as female characteristics. Okay, changes in bone structure of the pelvis, breast development, menstrual cycle. Those are characteristics, secondary female sex characteristics. And so we talked about this the other day with human growth hormone, but those of you that follow sports, what could you tell me about testosterone?
Like you can take it, I guess, to get more muscle.
Yeah, that some people, that's what, when we talk about steroid use, steroids are generally some testosterone-like molecule that acts in a similar way, and elevating a person's level of testosterone causes them to be able to develop larger muscle mass. Okay, and so testosterone is a performance-enhancing substance that's banned in just about all sports. There are times when people are given testosterone by a doctor or prescribed testosterone if they have low testosterone levels. But when it's done to sort of enhance performance, things like that, then it's done against the rules and it's illegal as well. And the problem is that because testosterone not only affects muscles, but it has wide-ranging effects throughout the body, there's a whole host of health consequences that sort of go along with a person giving themselves artificially elevated testosterone levels. Trevor?
There's a guy that, like, I remember there's a guy that's like named Super Freak and he takes like 40 like steroids
Oh, really?
a day, and that's like 400 times like the regular testosterone a day.
And what's his health like? Was this like a documentary or something?
There was a documentary and like his bicep muscles look up to you.
Yeah. Some people take things definitely to extreme. And it's certainly not healthy. They may be strong, but not healthy. All right. Any last questions about endocrine system? All right. So this last section in this packet of notes is about the lymphatic system. It's one, we don't talk about all that much, but the lymphatic system is a system of vessels that run throughout our body, but not blood vessels. They don't carry blood, but they carry lymph, which is the term we use for body fluid. All of our cells, all the tissue of our body are surrounded by this fluid. It allows materials to diffuse in and out, so it's all throughout our body. And the lymphatic system helps move this fluid around, take it from one place to another, and also filter it out and remove harmful bacteria and things that need to be filtered out of the body. Okay. So it's also considered part of the immune system because it does help to destroy pathogens, the organisms that can cause disease. So they carry this fluid. The fluid is called lymph. That's why it's called the lymphatic system. And you've also probably heard, where else have you heard the word lymph? Heard about another organ? Yeah, lymph nodes. Lymph nodes are a part of the lymphatic system. Okay. Where you see on this diagram, the green are the main lymph vessels, and the little circles on them, those are the lymph nodes. Okay, so this fluid circulates through our body. On its way, it picks up these unwanted materials, and it travels to these nodes before the fluid goes back into the circulation. When it's in these nodes, they're white blood cells. Oh yeah, you guys didn't have this. Yeah, you got to write out the whole section. Ooh, I know, it'll be all right.
Mr. Curious.
Back when, Mr. Curious must have made these and forgot to put that in.
Are you sure?
Yeah, I'm sure.
Positive.
It's a mistake, it's not.
Nobody's
So it's not your fault, it's Mr.
No,
Curious'
it's
fault.
never my fault.
You tell him, Nicolette.
So these lymph nodes, these areas where the lymph is filtered, they can trap bacteria, they can trap viruses, and basically destroy them. Inside of the lymph nodes are cells called lymphocytes. They're a type of white blood cells that can engulf and destroy these pathogens. Have you ever had a cold or something and your mother or grandmother felt your neck and said, oh, your glands are swollen? Or your neck might be sore, like kind of swollen? So those, what they're really saying, what they're really talking about is your lymph nodes. If you have a collection of lymph nodes, this diagram shows there's clusters of them up in your face, in your cheeks, in your neck, under your arms, in the armpits, in the groin area. They're spread throughout the body, but there's certain areas with more of these lymph nodes. And so when you are sick, they do swell up. And they swell up because they're working, because they're actively filtering out these bacteria or viruses that are making you sick. So they may be sore because they're doing their job. Once they've done their job, once you heal and once you get over your illness, then they'll go back to their normal size. But they're helpful and they're like that for you, Julianne. Sometimes they could be sort of closer to your surface and you can feel them. When they swell up, you could feel them. Depends on sort of your own.
I have a weird ball over here.
Yeah, sometimes it could be like just sometimes little cysts grow and stuff, just something that happens. There's other types of what we call lymphoid tissue throughout our body. You've probably heard of tonsils, adenoids, the spleen. Yeah, so did my daughter. We'll talk about that in a second. But yeah, lymph sort of moves from these lymph vessels into circulation. It's constantly moving throughout the body from one place to another. It gets forced into the capillaries. Along the way, this unfiltered lymph, this body fluid that may have these pathogens in it, gets into a lymph node where you have these lymphocytes, these white blood vessels. They destroy the bacteria, and then the filtered, sort of cleaned up lymph can go back into circulation. Okay. And again, you see some diagrams that show where the lymphatic system is. Again, lymphoid tissue. Things like the thymus gland.
Mr. Archer, do that one?
The lymph nodes. No, if it's cool.
Oh,
I did
you
it.
finished.
Yeah. The spleen, tonsils, adenoids. These are all sort of lymph tissue with lymph nodes that help to filter out various things from our body. And again, for example, my daughter, my oldest daughter, when she was younger, she got strep throat 4 or 5 times every winter. And her tonsils, if you're in the back of your throat are your tonsils, they're lymphoid tissue. And hers were very large, and they would trap bacteria back there, and she just get strep throat recurrently. So after a while, the doctor said, well, we probably should remove them, because getting strep throat that many times is not good for you. And so the other thing is, whenever she was sick, they would really swell up. She'd have trouble breathing. She would snore really loud. After they did the surgery, so they removed her tonsils and adenoids, which are also up in that area of the head. And afterwards, she never got strep throat again. She never snored anymore because they removed some of that tissue. And you have other tissue, other lymph tissue that can take over, other lymph nodes and so on. So you could still be fine having those parts removed. Just depends on each person's situation. They don't do it quite as much, I think, today as they used to. It used to be fairly routine for a person to get the tonsils out. They don't do it quite as much anymore. All right, any questions about the lymphatic system? Now, we talked about elephantiasis. We don't have this slide. We talked about it briefly when we were talking about invertebrates. Because elephantiasis is caused by a flatworm, a parasitic flatworm, that works its way into a person's lymphatic system and basically clogs it up. And when it clogs it up, it means this body fluid can no longer be properly distributed around the body, and so it starts to collect, leading to huge amounts of swelling, and tenderness, and eventually infections, usually in the lower extremities, in the feet, in the legs. Leanne? It's a parasitic worm that lives in the soil and in the water. It's not a parasite that is common throughout the world. It generally affects people in areas where there's sort of poor sanitation, where wastewater can mix in with water that people are in, or consuming, or walking in. So it's not a widespread illness by any means. Often you find it in poorer countries, but it is something that happens, and it's related to the lymphatic system.
That's all like
I'm going to show you. Yeah, I'm going to show you. All right, Trevor?
Isn't it like in Somalia, because isn't there like an insect in Somalia's water that if you drink it, makes
I mean, there's a whole host of, we talked about other parasites with invertebrates, so there's a whole host of parasites that cause all sorts of diseases. That one's not specifically this, but there are other. All right, so if you don't like the graphic pictures, you may want to avoid. So we start off, with, this is an example. So this person, you see their right leg is obviously quite swollen compared to their left leg, which also still has some swelling. Now it's not, people say, well, can you pop it or drain it? It's not that there's like a bubble of fluid in there. It's basically all of the tissue in that part of the body is just inundated with this fluid. It's just all surrounding it, leading to the swelling. So no, you can't drain it. There are medications that can help to kill the worms causing the obstruction, but there are also other problems that come about after a person's infected by this.
Are there any ways you can remove it before?
I think if the parasitic infection is treated early, then I think it can be okay. But once you'll see some of these pictures, the extreme infections that, there's not anything that's going to return that lymph.
So there's worse.
Yeah, so another example, here you see a person who has the infection. the infection in their left foot, which is obviously swollen, versus the right foot, which is normal size. This is just their clothing. This is not the width. Some people thought that's how narrow their leg was. It's behind there. But this is a narrow foot and part of their leg versus one infected with elephantitis.
Jesus, it's a Hulk.
Here's another extreme,
Oh my God.
Is that real?
and there's another,
Oh.
and here's probably the worst I've ever seen. So you can see that let go unchecked can be extremely debilitating. It's not, there's not a bubble that you could drain or pop. It's all the fluid. It's just, all right,
Oh.
It's not a trick.
I've seen.
next packet. So let's move on.
What was that?
Oh, dude, that's disgusting.
So digestive system is our next system to talk about. And again, this is probably one you guys are fairly familiar with. So the digestive system's purpose is to break down food. You eat the pieces that are usable. You know, you just went and let's say, you had chicken nuggets for lunch today. So you ate a double order of school chicken nuggets. Right now, they are in your stomach. They are being broken down. So little chunks of chicken nugget do not flow through your arteries to all of your cells, entering your cells for them to use. The meat that's in those chicken nuggets has to be broken down into much, much simpler, much smaller molecules. So, you know, proteins, a lot of protein in chicken, that gets broken down into small little amino acids, okay? Or the breading probably gets broken down into glucose. It's, you know, starch and stuff like that. That gets broken down into simple sugars. And those are things your body can absorb and your body can use. So the process of digestion is breaking these large molecules into small molecules and then getting them into the blood to supply it. It starts in the mouth, okay? And in your mouth, when you shoot up those chicken nuggets, you're starting to accomplish two types of digestion, mechanical and chemical digestion. What do you think mechanical digestion is? Emma?
Chewing.
Yeah, it's chewing. It's actually physically breaking a large chunk of food into smaller pieces of food. Okay? You digest foods easier if they have a large surface area, okay, that is exposed to enzymes and acids. So yeah, that's mechanical. That's a physical change. We just talked about that in the last unit, physical versus chemical changes. So that's a physical change. You're just physically breaking up a large chunk of food into many small chunks. So this guy eating this veggie burger here,
Veggie burger. That's a burger.
that's a veggie burger.
Veggie burger.
Bacon on
That's,
it.
that's not bacon, that's bacon.
Fake.
It's bacon.
It's fake. It's fake. Fake.
I have bacon BLTs all the time.
Bacon BLT.
Morning Stars.
No, it'd be FLT. FLT. Bacon, lettuce, tomato.
Alright, so anyway, mechanical digestion is breaking this food into tiny, small little pieces. But then there is the chemical digestion, which is, as we talked about last year, a chemical change, where you're actually transforming these large molecules into smaller, simpler compounds. So we end up with a new substance. It's a chemical change. That actually starts to take place in the mouth as well. Okay? Saliva is not just water in your mouth. It's a mixture of fluid with enzymes that start to break down your food. The main enzyme in saliva is something called salivary amylase. And salivary amylase is an enzyme that takes starch, a large molecule, and actually breaks it into simple sugars. You can actually, if you take like a saltine, like a starchy cracker, like a saltine cracker, if you chew it up, but keep it in your mouth for a long time, keep chewing it, let your saliva work on it, eventually it starts to taste slightly sweet. And that's because those starch molecules are being digested by this enzyme in your saliva into simple sugars. Here you go, Noah.
Keep on chewing it, just
So the saliva is produced in glands that are in your mouth, under your tongue, and so forth. Salivary glands. There's one right under your tongue, the sublingual salivary gland. In fact, have you ever been like reading a book and like yawn and a spray of saliva?
Yeah.
Oh, no, that happens when I like, use the mouthwash.
Some people can actually do it purposely. They can like make it happen. I don't know
No,
exactly
that,
how.
no, like I'll drink the mouthwash and I'll spit it out and I just go like that and I'll just like
Yeah, no,
like,
Oh yeah, that's just because under your tongue you have a salivary gland that sprays saliva into your mouth. If your mouth happens to be open and your tongue up, then sometimes it sprays out of your mouth.
Oh, that's weird.
Yeah, that's how it
Next
works.
thing you know, your books are like white and stuff.
All right, so let's look at this here. So if we follow our digestive tract, so our mouth, obviously we chew and start digestion, travels through the esophagus. Now the esophagus is this tube, this muscular tube that takes the food from our mouth and brings it down into our stomach. But food doesn't get in your stomach because of gravity. It doesn't like just fall into your stomach. The esophagus is made of these rings of muscle. And we talked about the muscles, and they contract. And so this ring of muscle, the one on top contracts, then the one under it contracts, and the one under that, and the one under that. And it basically squeezes that food from your mouth down into your stomach. Okay? So it's like if you took a tube of toothpaste and you squeeze it from the bottom up and force the toothpaste out. That's how the food gets into your stomach. It's being pushed down by these contractions. That process is called peristalsis. It's the name for that contraction of those esophagus muscles that move that food along. You could even, you could drink a glass of water standing on your head.
No, you can't.
As long as once you swallow, the muscles in your esophagus will force that liquid up into your stomach.
Let's do it right now.
Because that's how they work. Again, it's not gravity, it's the muscular contractions that move food. Well?
I was watching like Ripley's Believe It or Not, and this guy was in an accident, so I think like his esophagus didn't work or something. So he either had to die or eat like constantly, and when he ate, you could see, like he didn't have his shirt on, you could see like the food, and he had to like push it down.
Really? I never heard of that.
Oh,
I don't know.
So the other thing is that sometimes this peristalsis happens in reverse. And what would that be? Yeah, vomiting is when those muscular contractions are sort of working in reverse and you expel the contents of your
Wait,
stomach.
why does it happen?
So that's a good question. So is there a value to vomiting?
Yes.
Liam, what would it be?
To get rid of bad things in your stomach.
Yeah, vomiting is an adaptation. We talked about evolution. Vomiting is an adaptation because you vomit when you're sick, when you've eaten something that could cause an illness to you. That's because your body is trying to expel some substance that could make you sick, and that's why we vomit. Certain tastes can cause a person to vomit because certain poisons have a distinctive taste, and those poisons obviously you don't want to ingest them, and so they trigger a vomiting response as an adaptation. So
I want to draw sounds kind of disgusting, but like when some people like they eat poison and stuff, like when they throw up like up their intestines and everything. Like, why does that happen?
That's fairly rare if you have like prolapsed intestines and stuff. Yeah, it's not very common. Your intestines can come out. Yeah. We're off to
So, what would be the case like when my blood sugar gets high? Sometimes like I get I get sick and then I throw up. But like, how would that cause?
How's that adaptation? How's that helpful?
No, how is it like? Yeah, like how does it cause?
I don't know. Maybe I'm not exactly sure, but that high blood sugar, causing you sort of to feel ill, and that's just one of your body's responses to that overall high blood sugar that you're experiencing. Gabby?
Then why do you throw up if you touch that thing in the back of your head?
Well, that's called a gag reflex. Is that you gag? So if you have food in your mouth and it's in the back of your mouth and you swallow, you don't gag. Because you know, your brain knows that you're swallowing food and it's supposed to be going down your throat. But if you don't, if your brain knows that you're not chewing up and about to swallow some food, then that gag reflex prevents things from accidentally going down there. Also, we're going to talk about respiratory system. You have two tubes going down your throat. Your trachea, which carries oxygen and air into your lungs, and then your esophagus, which carries the food into your stomach. It's important that your trachea has a flap that covers, when you swallow food, the flap over your trachea covers up so no food goes down your trachea. What's it called when food does go down your trachea? Yeah, choking. Or if you get a little piece of food in there, you might start coughing to expel that so it doesn't, you don't choke on it.
Or when you drink and it goes down the wrong
Yeah, or if you drink and you inhale some of that water, some of that liquid goes into your trachea and down into your lungs, you start coughing and spitting it out because air is supposed to be going down that
So like when
pathway.
you eat too fast or if you drink too fast, that's what happens?
Yeah, sometimes. Or, I mean, if you swallow some big Dorito and you didn't chew it up well enough, you know, it's going down your esophagus and it hurts and strains. Yeah, it takes a while for it to get down there.
Or it hurts when it goes on.
No, hiccups have to do with the respiratory system. That's later on. All right, quickly, next one.
My brother swallowed
All right,
a lot
guys,
of water
listen.
on accident. He was swimming and he swallowed a lot of water and it went down his trachea and he stopped breathing.
Well, what's it called when you inhale water?
Drowning.
Yeah, that's what drowning is, inhaling water and filling your lungs with water, making you unable to breathe. All right, last one, Oscar, then we gotta go.
Come on.
Hold on.
How come when you smell something you gag? What do you
Again, it's a reflex because what smells are going to make you gag?
Trash.
Here's the story. One of my daughters, which will go unnamed, I made her go. Maybe I made her go in the backyard and she had. All right, so I told her to take out the dogs, but she went. She took them out, but she didn't pick up the mess they left. So I made her go out there, and she said, I can't do it. So she had the bag in her hand, she was picking up, but as she was doing it, she was gagging. So why is that an appropriate response to picking up dog feces?
It feels weird.
Not why, Liam?
Because the smell told her brain that it wasn't good, so she started.
Yeah, because obviously there could be bacteria and other things in feces that we want to avoid it, and us gagging, us thinking that it smells gross, is an adaptation to avoid those types of materials.
Spinach.
Spinach doesn't make you gag. You may not like it. I don't think it makes you gag. All right, I'm moving on.
Wait, no, this is
Stomach.
I'm recording.
So we'll get these later if we have chance. All right, from our esophagus.
Next, human stomach.
Then we have the stomach, the next destination on the path. So the stomach is sort of a muscular, hollow organ, has all these ridges inside. And it also is filled with strong acids, hydrochloric acid, which helps to do what?
Break down.
Yeah, break down the foods that we eat. Okay? That's why when people say, talking about reproduction of the babies in the mother's stomach, it's not. That's not a good place for a baby. It's filled with hydrochloric acid. So the stomach turns the chewed up food into a soupy sort of slop of a mixture
Ew.
as it gets further digested.
Why do you puke up?
So you know if you get sick soon after eating, the foods that you vomit will still be somewhat recognizable.
Yeah.
If it's been, 5 or 6 hours since you ate, it's just like a pile of liquidy slop, right?
Yeah.
Because that food has been broken down into other molecules.
When I was doing the kicking contest this year for
Liam.
okay. So at the carnival this year, I was doing the kicking contest and some got up my nose and I kind of like breathed through my
I
nose and
remember
went down.
that.
Yeah.
but like when I came up, it was like all like soup. And it was only like 5 minutes after I ate.
I don't exactly know what was going on there. So the stomach now.
One time I threw up out of my nose.
That's not good.
Oh yeah.
And it hurt a lot. I was like
Alright, so if you look up here later on,
it came out of my nose.
your mouth and your nose, they're all connected, and your nasal cavity leads down into the back of your throat. And so, yes, you know, if you were drinking soda and then you cough, some of that goes up into your nasal cavity. If you vomit, some of that can get up there as well. So, yes, hold on, they're all connected. Noah? Alright, go ahead, Noah.
How come you like throw up if you see or hear something that you find gross?
Again, it's just you think things are gross because generally you want to avoid them, and so it's your body's way of an aversion to whatever that thing is. So some people are more sensitive to, you know, whatever it's blood or something gross looking than other people. All right, Julianne, quickly. All right, we're not going to get into the one time I watched a YouTube video. Yeah, Sidra.
What about when like your nose gets stuff?
Again, yeah, it's in your nose and your nasal passage, and you can suck it in. It can get into your mouth. Yeah, it's all connected. All right, can we finish small intestine? Yeah. So from our stomach, this partially digested food makes its way into the small intestine. This is where most digestion and absorption of material happens. Now the small intestine is called small not because it's short, but because it's narrower than the large intestine. So on average, a person's small intestine in an adult would be about 25 feet long. So if you took out my small intestine, stretched it across the room, it would go from me to Caleb. Yeah, so it's all wound within the abdomen, and so food has to travel that entire path in order to make it through the digestive system. So you can see down here all wound about within the abdomen. And along the way, various enzymes are added to break down the food. And also, this is where the nutrients in the food are absorbed through the wall of the intestine into the bloodstream. Because it takes that length in order for the food to be fully digested and to absorb the maximum amount of nutrients. It takes a long time for that to happen. And so it needs to travel a long path. And different types of living organisms have different types of digestive tracts, depending on what types of food they eat, how long it takes to digest, and so forth. So along the way, enzymes are added by various organs. One is the liver. Okay, so the liver has multiple functions, but one of them is to produce bile. Bile is a digestive enzyme that breaks down fats. Okay? So fat is a nutrient, and bile can help to digest it. That bile produced by the liver actually is sent to the gallbladder where it can be stored. In addition, the liver is also responsible for the removal